Hello everyone, welcome to the Think Mode. Today we are going to know about some interesting facts about the Earth. Earth is our home and a fascinating place it is. We've spent our entire existence here and, in some circumstances, know more about other planets than parts of our own planet. However, what we have discovered about Earth is truly astounding. So, let's take a look at some amazing facts about our planet. 60 tons of cosmic dust fall to Earth daily. Cosmic dust sounds magical, but chances are you've inhaled a good amount of it just on your way to work. On a daily basis, dust from meteorites, comets, and other solar bodies fall to Earth in tiny particles that increase the levels of sodium and iron in the planet's atmosphere. Scientists studying the phenomenon estimate that altogether, about 60 tons of cosmic dust is falling to Earth daily. Earth is not actually a sphere. Contrary to what most people may think, the Earth is not actually a perfect sphere. It is actually a shape called an oblate spheroid. But what exactly does this mean? Well, put simply, the Earth is wider at the equator than the poles. It is, basically, a flattened sphere. This shape is a consequence of Earth's spin about its axis. The difference is very slight, on the scale of the planet, with the diameter of the Earth at the equator about 26.7 miles, 43 kilometers, larger than the pole-to-pole diameter. Earth is a planet that records its own history. Layered in the planet's rocks are physical, chemical, and biological inscriptions that chronicle what the world was like at different points in Earth's history, Knoll says, citing the Grand Canyon as a prime example. While it's spectacular to see, it's also a giant library. Each layer of rock has its own story. Rocks at the bottom tells from around 800 million years ago, when there was oxygen in the atmosphere but probably not enough to oxygenate the ocean. Above those rocks are ones from 500 million years ago that tell stories about the emergence of land organisms. Lightning never strikes twice, but does strike a lot. Amazingly, there are somewhere in the order of 6,000 lightning strikes on Earth every single minute. Yes, that's right, every minute. And, of course, lightning often does strike the same spot twice. Between 2015 and 2020, the Willis Tower in Chicago was hit by lightning 250 times. Even people can be hit more than once. Park Ranger Roy Sullivan was struck by lightning 7 times in his life and survived each time. Earth's gravity isn't uniform. If Earth were a perfect sphere, its gravitational field would be the same everywhere. But in reality, the planet's surface is bumpy, and water flow, ice drift, and the movement of the tectonic plates beneath Earth's crust all change the pull of gravity. These variations are known as gravity anomalies. A mountain range such as the Himalayas causes a positive gravity anomaly. Gravity is stronger there than it would be on a featureless, perfectly smooth planet. Conversely, the presence of ocean trenches, or dips in the land caused by glaciers millennia ago, leads to negative gravity anomalies. NASA's Gravity Recovery and Climate Experiment mission, orbiting above us, is mapping Earth's gravitational field in unprecedented detail. The Moon is not Earth's only companion. There are 2 other bodies orbiting near Earth that are sometimes referred to as moons, though they are not strictly worthy of the title. Discovered in 1986, 3753 Cruithne is an asteroid that actually orbits the Sun. Since it takes the same amount of time to orbit the Sun as Earth, it looks as if Cruithne is following our planet. Its orbit, when seen from the perspective of Earth, appears bean-shaped. Asteroid 2002 AA29 also orbits the Sun once a year, following a more bizarre horseshoe-shaped path that brings it close to Earth, within about 5.9 million kilometers or 3.7 million miles, every 95 years. Because of its proximity to us, scientists have suggested collecting samples from AA29 and bringing them back to Earth. Earth is on the move. You may feel like you're standing still, but you're constantly moving fast. Depending on where you are on the globe, you could be spinning with the planet at just over 1,000 miles per hour, according to Space.com. People on the equator move the fastest, while someone standing on the North or South Pole would be perfectly still. Imagine a basketball spinning on your finger. A random point on the ball's equator has farther to go in a single spin as a point near your finger. Thus, the point on the equator is moving. The planet is recycled. The ground you're walking on is recycled. Earth's rock cycle transforms igneous rocks to sedimentary rocks to metamorphic rocks and back again. The cycle isn't a perfect circle, but the basics work like this: magma from deep in the earth emerges and hardens into rock. That's the igneous part. Tectonic processes uplift that rock to the surface, where erosion shaves bits off. These tiny fragments get deposited and buried, and the pressure from above compacts them into sedimentary rocks such as sandstone. If sedimentary rocks get buried even deeper, they cook into metamorphic rocks under lots of pressure and heat, according to Dorling-Kindersley. Along the way, of course, sedimentary rocks can be re-eroded or metamorphic rocks re-uplifted. But if metamorphic rocks get caught in a subduction zone where one piece of crust is pushing under another, they may find themselves transformed back into magma. Earth used to be purple. Well, life on early Earth may have been just as purple as it is green today, suspects Shildas Sarma, a microbial geneticist at the University of Maryland. Ancient microbes, he said, might have used a molecule other than chlorophyll to harness the sun's rays, one that gave the organisms a violet hue, he suggests. Das Sarma thinks chlorophyll appeared after another light-sensitive molecule called retinol was already present on early Earth. Retinol, today found in the plum-colored membrane of a photosynthetic microbe called halobacteria, absorbs green light and reflects back red and violet light, the combination of which appears purple. The idea may explain why, even though the sun transmits most of its energy in the green part of the visible spectrum, chlorophyll absorbs mainly blue and red wavelengths. The planet is filled with riches. And these vast seas are rich, holding more than 20 million tons of gold, according to Forbes. But don't grab your mining hat just yet. The metal is so dilute that each liter of seawater contains, on average, about 13 billionths of a gram of gold. Undissolved gold is also tucked away in rocks on the seafloor, and though there's no efficient way of getting at that precious metal, according to NOAA, if we could extract all of it, each person on Earth could have 9 pounds of the shiny stuff. There was a supercolossal eruption. The largest volcanic eruption recorded by humans occurred in April 1815, the peak of the explosion of Mount Tambora, according to NOAA. The eruption ranks 7 on the Volcanic Explosivity Index, which goes from 1 to 8 and is somewhat akin to the magnitude scale for earthquakes. The explosion is said to have been so loud it was heard on Sumatra Island, more than 1,200 miles, 1,930 kilometers away, Life Science previously reported. The death toll from the eruption was estimated at 71,000 people, and clouds of heavy ash descended on many faraway islands. The skies dazzle with dancing lights. Auroras occur when charged particles from the sun are funneled toward Earth by the planet's magnetic field and collide with the upper atmosphere near the poles, according to Royal Museum Greenwich. They are more active when the sun's activity peaks during its 11-year solar weather cycle, according to Space.com. The southern lights, also called aurora australis, are seen less often than aurora borealis, the northern lights, because few people brave Antarctica's dark, freezing winters. Earth's inner core is hot. Really hot. The temperature of the inner core is estimated to be between 4,940 to 8,540 degrees Fahrenheit. The high temperature comes from 3 main sources. There is residual heat left from the Earth's formation, and heat is generated by gravitational forces from the sun and moon as they tug and pull on the inner core. Finally, the radioactive decay of elements deep within the Earth also produces heat. I hope you like this video. Please like and subscribe to my channel and click the bell icon to get more videos. See you soon.